Hello YouTube, De-bodgery here. This is the battery pack from a Mini Motors Dualtron Futecher, whatever, Futecher mini scooter. Yeah, they're like 1650 watts or something like that. Anyway, on Friday I had the opportunity to look at one of them, which I'd never seen inside before, and I was replacing several wires, or several pins on several wires, because they had sat in some water and gotten badly corroded. And that was one of two problems. And the other thing is that the pack wasn't discharging or showing any voltage anymore. So here's the wires from the thing, and I was able to put my multimeter across those, and sure enough, there was nothing here. So I knew that something was wrong with the pack, and so that got pulled out. We didn't know how to get the pack out of the thing, and contacted Dualtron, who also didn't know how to get the pack out of the thing, which was weird. So anyway, figured it out. Their only suggestion was to pull it out the back, which is, well, a pain in the ass. You have to pull all the rear suspension out, you have to pull the rear back swing arms off, a bunch of wiring, things like that. Wasn't exactly what I'd call ideal or easy. Whereas the front, which is where I was already working anyway, that was already partly disassembled, and I could see that there was an aluminum retaining bracket inside the end of the aluminum extrusion that mounted the handlebars and front wheel to, so that was actually really easy to take apart. All I had to do was take some screws out and pull some wires back, and then the whole thing came off. You know, that retaining bracket did, and then, well, this slid right out the front, so that was way easier. I thought it was sort of strange that Dualtron didn't know how to get their pack out. Anyway, yep, so here it is. And as it turns out, BMS is bad. Okay, on the bottom, you can see all that shiny stuff on there. That's because it's aluminum on here. And this sat inside this long extruded, tunnel kind of a thing, and it doesn't have any buffering on the ends of it, so the whole thing kind of can slide back and forth like this in its space, and that's why there's this scrubbing on here. It's because the bottom of the battery box is literally rubbing on the aluminum extrusion. On the side here, there was some high density foam on both sides, so that kept it from moving side to side. But it was a loose enough fit that it could still do this and scrub. But anyway, an ABS box, it's not waterproof, but I would say that that's probably not important. Unless you throw this in a lake or a river, water's not going to get into the pack anyway. It says 52 volt, 20.8 on the top of it, because it's a 20.8 amp hour pack, but it's 57.8 volts of full charge, so I'm guessing 52 volts is like nominal. There is a partly scrubbed away code here that says 02 something 0605, so you tell me what that means. I don't know. Anyway, yeah, just a basic plastic ABS box. Plenty stout enough for the job I had to do. Can't really complain about this. So let's set that on the floor. Oh, and by the way, that was all held together by 4 M5 screws. Okay, so this is the actual pack itself, and this is all fine. These are the cells say HFZH on them, and I forget what the Mini Motors website says. Some Sinotech or something like that, Chinese cells. And so they say on them 18650-2600 milliamp hours on them. Couldn't find the darn things, but I've seen these same cells before in other small scooters. So, Dualtron or Mini Motors or whoever built this pack, they basically just used something that was readily available and cheap in Chinese, because most likely these cells are not going to be anywhere near as good as, like, say, Samsung's or Panasonic's or whatever. But then again, this is a fairly low amperage scooter, and so that matters less, that you use good quality cells. All the cells, I flip that down, are decently well spot welded together. Not really worried about that. This is battery minus, and this is battery plus. The nickel is all 0.15 millimeter nickel, but for the low amperage of this EV, that's probably not a big deal. This little tab right down here, this is the the battery minus end where it solders down to the BMS, and here's the battery plus end where it solders down to the BMS. And then the BMS, it used to be all these tabs. I had them bent up and I've kind of folded them back down again. But the BMS sat in that space, and then all those tabs soldered down onto here. So pretty easy way to implement a BMS without too much trouble, no wiring or any kind. The BMS does have 2 temp sensors on it, so one here and one here, so that's good. A lot of BMSs don't. In fact, the last time I took one of these things, a BMS apart, it didn't have any temp sensors at all, which is okay-ish, but you're better to have them. If the pack gets over some voltage, or over some temperature rather, it'd be good to be able to cut back current, or shut off the battery pack altogether, via the main discharge MOSFETs, than it is to let the pack go thermonuclear and catch fire. So this again is the battery minus connection. It's got a fairly large trace here. We've got some shunts for current sensing, and then this trace right here then dips to the other side of the board, and then comes out right here at the MOSFETs. So these are your discharge MOSFETs, and there's only 4, but there's a space for 2 more, and they're HY3510s, which are 100 volt MOSFETs. I forget the amperage for them, but these are Chinese MOSFETs. They're not like magnet chips or AOTs or something like that, but it's probably fine because this is not exactly a high amperage implementation. The charge MOSFETs are these 2 little guys right here, and they are KND 3308s. No idea what those are, but there's 2 of them in parallel, and that yellow wire right there is charge minus. So, if you start overcharging the cells for whatever reason, or, they're out of balance badly and one of them's over voltage, well, those guys will turn off so you can't push more current into the pack. And then, these 4 here, they're for discharge purposes or over temp purposes, things like that. Cells drop too low, those guys will turn off so that you can't discharge anymore. So, this BMS was off. I couldn't get it to power back on again. So, I'm guessing that something in the MCU was showing a fault, and it was keeping these MOSFETs turned off. But I didn't get it working again. But like all the cells, they all test fine. They're all like at 3.8 volts. So maybe this guy went bad. Maybe some other monitoring components went bad. Don't really care. The pack's going to get replaced. So that's really not that big of a deal. But yeah, something on this BMS basically stopped behaving correctly. Because it wasn't the cells. These are all testing to correct voltages. I don't see any problem with that. It could very easily be something like a temp sensor is showing some wonky reading, and so it's like goes into panic mode and just shuts off. It could be anything silly like that. Anyway, basic BMS. It's got a fairly intelligent MCU on it. It's got some programming settings that can be made. So it's got this little programming port over here. So different settings can be made, like probably for like discharge rates or current rates, or maybe cell voltages or something like that. But a semi-intelligent charge controller that can handle up to 16 cells, and this is a 14 cell pack. So it's 14S8P. To basically get that 57.8 volts. And this can handle up to 16 cells. And there's no programming as far as I can see in the CPU here for the cell count. It just auto detects that when cells are plugged in, and that's that. The few settings that you can make on the thing, they must be pretty basic. Can't be much, but still, nevertheless, there's a fair bit of intelligence in that silicone. It's got a little analog to digital converter inside there that it will switch between each of its 16 channels, once every 1/10 of a second or so to make sure cell voltages are right. It's able to manage each one of these balance circuits individually. So there's a fair bit of brain pan inside that little tiny chip. It's not a bad BMS. It's cheap, but it's not a bad one. I've seen much worse than this. I would have to say I would rather have this BMS and some of the stuff where it's completely discrete components, because this is going to have much better integration. That little chip is going to have much better handle on battery status than most anything else. Bottom side of the board is nothing. There's just a piece of fish tape and some traces, and that's it. Over here, so this is P minus, so that's basically, power minus coming off those MOSFETs, and then C minus is over here. It's great that they have a separate P minus and C minus. This is my preferred way of having BMSs. And of course, here's your two battery plus wires. One's going to the charging port, which is a Dean's T connector, and the other one goes over to this XT30 connector. So this is all pretty reasonable stuff, and this is a low discharge BMS and battery solution, so I'm not too worried about that. Anyway, I hope that helps folks out with the Futecher battery pack, and that people are generally able to, satiate their curiosity on how one of these things works. Well, take care, folks. This is De-bodgery saying be safe. Stay away from that damn SARS virus. I got a cold. Yeah, I went to a bar. Got a cold at a bar. Can you believe it? But, hey, at least it's not SARS, right? I already had that.